Hello again, everyone. Today's lesson, we're going to just look at a few more examples of compound interest and what happens if you change the compounding frequency. So the first thing we need to do is we need to learn some new terms that we're going to be using throughout this section. So there are a bunch of different compounding frequencies. So the one that we will be using the most is compounded monthly. So what does monthly mean? It means 12 times per year. There are 12 months in the year. Monthly means 12 times per year. Now, the next one here, a lot of people actually struggle with because this is how most people get paid. Most people get paid bi-weekly, which means every 2 weeks. The problem is there's a misconception out there that people think that they're within a month, that there's 2 bi-weekly periods, meaning every month is 4 weeks and you get paid twice a month if you're getting paid bi-weekly. But that's not quite true. There's a small calculation that you have to do to check to see how many bi-weekly periods there are for the whole year. And that calculation goes like this. Well, how many weeks are there in a year? There are 52 weeks. Sorry, my technology's messing up on me here. So there are 52 weeks in a year. You have to divide that by 2 to figure out how many bi-weekly periods are. So we're talking about 2-week periods. So how many times does 1 year get divided up into 2-week periods? And that's actually 26 times. Now, if you did the misconception of every month has 2 bi-weekly periods, you would get 24 here, and that's actually wrong. So I'm going to write in brackets here, not 24, because that's the misconception. Okay, it is 26 bi-weekly periods. So if you get paid every 2 weeks, there are, I believe, 2 months of the year where you actually get 3 payments instead of just 2. Semi-annually, mortgages are often compounded semi-annually. Mortgages we usually look at in grade 12. But just so you know, semi-annually means twice a year. So 2 times a year. Now, one thing to be careful with, I've seen some students make the mistake of saying, oh, semi-annually means every 6 months. So they think that they're looking at the number 6. But every 6 months means twice a year. So both of those things are the same concept, but the number that we need is how many times per year. So every 6 months is twice per year. So be careful with that idea as well. Quarterly. Quarterly is often how stocks will be talking about how well they're doing. So investments often will release a quarterly period. So you'll have quarter 1, quarter 2, and sometimes they'll tell you that about objects being sold. They'll say the object is going to be sold in the second quarter of the year or whatever. So quarterly, again, something to be careful with. If you divide the year in 4, which is the number that we need, that means every 3 months. And some students will mistakenly use the number 3 for quarterly, but you have to remember it's times per year, okay? So that's 4 times per year. It's right in the word. Quarter usually means divide by 4. So, and the last one, well, we've actually already talked about how many weeks there are in a year in the bi-weekly section. If it is weekly, then the number we'd be using is 52. So, when you're compounding, you're going to have one of those words. Now, I didn't put yearly. I guess I could put it at the bottom here. Yearly is the easiest one, and that just means once per year. So if you're looking for the amount of money you would have in the bank after a certain investment, here's an example of that. Okay, so find the amount in the bank if you invest $2,000 compounded monthly at 4% for 15 years. Now, one thing I forgot to mention here is after 4%, and actually I think I'm just going to type that in, they'll usually say all the time per year. Okay, so this here. Okay, so 4% per year for 15 years. Now this per year also throws people off. There's a lot of things that can throw people off in this topic, and that's why people have a difficult time understanding finance. Okay, but we talked about this in the last lesson about compound interest. When you say 4% per year, that's what the bank is giving you for the entire year. Okay, but they're dividing that up into small little chunks of monthly payments. So as I mentioned before, the two most important things to calculate, and I'm going to put the formula down here. Again, this is special I here. The two most important things to calculate in compound interest scenarios are always your I and your N. Okay, those are the two most important things. And if you understand how I works, it's going to be a lot easier to remember what you do to calculate I. Okay, so I is your interest divided by your compounding frequency. Okay, you're getting 4% for the year, but they're dividing that up into monthly pieces. So 4% divided by 12, which would be 0.04 divided by 12. And that's going to be a very small number, so we're going to use our calculator to figure it out. Let me switch over to the calculator here. So 0.04 divided by 12 equals 0.0033. So 0.0033, and I'm going to round it off to that number. So now we have to calculate our N value. Now N is the number of interest payments over the entire life of the loan, or the number of interest events that you're getting. Well, the life of the loan is 15 years. Okay, so we're going for 15 years, but each year we're getting 12 payments because it's compounded monthly. Okay, so if you went for 1 year, you'd be getting 12. If you went for 2 years, you'd be getting 24. If you went for 3 years, it'd be 3 times 12. We're going 15 years, so we have to multiply 15 times 12. So using our calculator, I'm going to do this off screen because it's not a difficult calculation to do. So 15 times 12 gives 180. So that means you're getting 180 interest payments over the life of the loan. Now we're ready to put everything into the formula. All right. So if you remember, A stands for final amount, which is what we're trying to calculate, find the amount in the bank, okay, is equal to the principal. The principal is $2,000 times 1 plus the interest rate. Sorry, not the interest rate, sorry, 1 plus I, little I, which is the interest per compounding period. Well, that is our 0.0033. To the power of N, which is 180. And then you just type this into your calculator to find the answer. Now, I'd like to briefly talk about this 1 plus 0.0033 again. It is such an important concept. I don't think it's a bad thing to repeat this. If you remember back to our exponential word problem lessons that we've done in the past, I had mentioned that this was our B value and that B was always related to 100%. Okay, so it's plus or minus a change depending on whether it's an increase or a growth scenario or a decay scenario. The formula for finance puts the 100% right into the formula, basically making this what I jokingly call dummy proof. You know those books for dummies, like Finance for Dummies, okay? So that people don't have to forget, or sorry, so that people don't have to remember that they have to add their little I to 100%. They put it right in the formula, all right? And that's just because of how important the finance formula is. They tried to make it as easy as possible for anybody to be able to understand and to use the formula. But that one is just that 100%, okay? And in this case, we're adding, so I'm going to delete the minus here. We're adding the change to 100%. So you're getting 100% of your money plus the little I value every month, okay? So I'm going to erase that so it's not permanently part of the note, because it might be a little bit hard to understand when you're reading the note later on. So let's use our calculator to type this in. I'm just going to switch over to the calculator here. Okay, so we've got 2,000 times bracket 1 plus 0.0033 bracket to the power of 180. And we're getting a final answer of 3,618 and 89 cents. So let me switch back here. So 3,618.89. Now we probably could round that up to 90, okay, which I think I'm going to do since it was 896. And that is how much money you'd have in the bank. So you put $2,000 in the bank, you walked away for 15 years, and you came back without touching that account, and you now have 3,618. So if I asked, how much interest have you made? And we talked about this again in a previous lesson. If you just subtract how much money is in the bank at the end, minus how much money you put in, that's going to tell you how much interest you made, okay? So, once again, talking about how realistic this scenario is, there are certain investments where you put money in and you walk away. But the normal way that we invest money is regular monthly payments or regular bi-weekly payments throughout, like, you know, the last 30 or 40 years of your life to try to invest for your retirement, for instance. That's another equation, and it's a much more complicated equation. So we're not going to look at that one. Actually, we're not going to look at it, I don't think, this year. Technically, that's usually taught in the grade 12 level. I might just show it to you at the end of the unit. We'll see. Okay, but this is just the easiest scenario that I can give you. That is still fairly complicated for all the different steps that are required. But I'm hoping that you're starting to get a little bit more used to this now. So let's move on to the next example. So you borrow $10,000 at an interest rate of 6% per year, compounded quarterly. So there's that per year again, compounded quarterly this time. How much will you owe after 5 years, and how much interest did you pay? So this is a scenario where you're borrowing money and the money is again being compounded. Again, not a perfectly realistic scenario. This doesn't usually happen, but just because it's a math scenario, we're going to look at it anyway, okay? So we already know our formula from the previous example. Let's calculate our I and our N. You always start with I and N in finance questions. So we're dealing with 6% per year, compounded quarterly. So if we go back to the table right at the beginning of the lesson, what number are we dealing with when we're talking about quarterly? Well, we're talking about the number 4. So that means we're getting 4 interest payments per year, which means the bank is dividing the 6% into 4 little chunks that it's going to give us every 3 months, okay, 4 times a year. So 6% is 0.06. We're going to divide that by 4. And I'm going to do this off camera. So 0.06 divided by 4 equals 0.015. And then our N value is how many interest payments are we getting over the life of the loan? Well, the life of the loan is 5 years, but we're getting 4 payments per year. So after 1 year, we'd have 4. After 2 years, we'd have 8. How many would we have after 5 years? Well, we'd have 20 interest payments. And now we can put all of that into the formula, including our original amount borrowed. So our final amount owed, in this case, our principal is $10,000. following the formula, it's 1 plus I, which is 0.015, to the power of 20. So this calculation I'll do on screen so you can see it. I'm just going to clear out some of the previous calculations here, and let's switch over to our calculator. So we've got 10,000 times bracket 1 plus 0.015, close the bracket, to the power of 20. And that's giving us $13,468.55. So switching back over to the smartboard, we get $13,468.55. And then the question says how much interest. Well, with a number like 10,000 going up to 13,468, pretty easy to calculate the difference between those two. So instead of showing the entire calculation, we know that we're making $3,468.55. And if you don't see where that comes from, just subtract the final amount by the original amount. Okay, so I'm hoping it's starting to make a little bit more sense as to why we have to divide by the compounding frequency. And if it's not making more sense, I hope at least you're going to remember that it has to be done. And over here for the n value, I hope you're starting to understand why we have to multiply by 4 instead of divide by 4. So let's do this one final example where we're going to compare 3 different compounding frequencies and see how does that change the final amount. Okay, so all 3 of these are investing $1,000 in the bank at a 5% interest, for 5 years at an interest rate of 5% per annum. Now here's that per annum that I mentioned in one of our previous lessons. Okay, per annum just means per year. It's another way of saying per year. All right. So for each one, I'm going to start by calculating the I and the N for each one. So I for compounded yearly. We haven't seen a compounded yearly since the very first examples. So remember, yearly just means once per year. So we're dividing our I by 1. So 5% divided by 1 is 0.05. Our N value is 5 years times 1, because it's once per year. So the first year you get 1, the second year you get 2, the third year it'd be 3. So it's 5 times 1, which is just 5. Compounded monthly. So it's still 5%, but this time it's divided by 12. 5% is 0.05, but we're going to have to divide that by 12. Okay? So I'm going to do that off camera. So 0.05 divided by 12 is equal to 0.0042 if we round it off. So 0.0042. Now our N value is going to be our 5 years again, but this time we're getting 12 payments per year. So it's 5 times 12. Now 5 times 12 I know is just 60. Okay, so 60 interest payments. So already we can see quite a big difference, right? Our interest amount is 0.05 for compounded yearly. Our interest amount is 0.0042 for compounded monthly. So it's a much smaller interest amount, but in the first case we're getting 5 payments of interest. In the second case we're getting 60 payments of interest. Okay? So for biweekly, we're still going to take our 5%, but this time we're going to divide it by biweekly. Now if you remember the calculation we did in the first table, biweekly means divided by 26. So that's 0.05 divided by 26. And again, I'm going to do that off camera. So 0.05 divided by 26 equals 0.0019. And this is an approximate value, so is this actually. So 0.0019. Okay, so again, smaller than the 12. All right. And our N value is going to be our 5 years again, but this time it's multiplied by the biweekly amount. So because we're getting 26 payments per year for 5 years, we have to multiply those two to find out how many payments of interest overall. So 5 times 20 would be 100, 5 times 6 is 30, so I believe this is 130. I will just quickly double check it on my calculator to make sure I'm not making any mistakes there. But 5 times 26. Yeah, I was right. It's 130. Okay? So now we've got our i's and our n's, and the rest is just substituting into the formula each time. So I'm going to write out all the formulas, and then we'll calculate all the answers one after the other. So we're doing $1,000 times 1 plus 0.05, to the power of 5. For this one, we're doing $1,000 again, times 1 plus 0.0042 to the power of 60. And for this one, we're doing 1,000 times 1 plus 0.0019 to the power of 130. Now remember, both of these are for all 3 of these are for 5 years. Okay, so all 3 of these investments are being invested for the same amount of time. The difference is the compounding frequency only. And how does that change our final answer? So let's calculate, and again, I'm going to do this off screen just to make it a little faster. So 1,000 times bracket 1 plus 0.05, close the bracket, to the power of 5. Oh, sorry, I made a mistake there. I put 100 instead of 1,000. So I believe I just have to move the decimal place 1, but I'm going to do again really quickly here just to make sure. 0.05 to the power of 5. Yeah, so we get $1,276.28. Okay, now we'll do the second one. So 1,000 times 1 plus 0.0042 all to the power of 60. And that gives 1,285.92 if we round it off. And now the last one, 1,000 times bracket 1 plus 0.0019, close the bracket, to the power of 130. And that one gives approximately $1,279.88. So remember, same amount of time in the bank, but look at the difference. Okay, I had to pause for a second there and check my answers because I wasn't sure, so I'm not sure if this makes sense to everybody. I just said the word sure a lot. Here's the issue. For this answer, it is currently smaller than that one, and that didn't make sense to me. I was trying to figure it out, and I think I just did figure it out. Here's the problem. We rounded off 0.0042. This was actually 0.00416, and then 66666, okay? We rounded this one off. It was 0.00192, and we rounded down, okay? So I just want to show you something on the calculator here. I'm not sure if you'll actually be able to understand it or not, but we're going to try. I want you to look at the last 2 calculations I did on the calculator, and I hope they're actually highlighting on the video. The last calculation I did, if you look, I did 1,000. Let's see if I can see. I guess I can highlight it like that. 1,000 times 1 plus 0.00416 to the power of 60, and I got 1282.84. And then I did 1,000 times 1 plus 0.00192 to the power of 130, and I got 1,283. Okay. So folks, I wanted to double check something because my three answers here stopped making sense between the last two, okay? The issue is that this number should be bigger than the previous number, okay? And for some reason it isn't. So I had to go find out why, because I know that the answer is supposed to be bigger. And the reason I found out is because of our rounding. So if I just highlight this number here, this number was supposed to be 0.004166666. So we rounded it off to 0.0042. This number here was supposed to be 0.00192, and we rounded it down to 0.0019. So the original number for the second one, we rounded up from 0.0042, and the other one we rounded down. And just that small amount of rounding threw off our answers, okay? So I actually double checked in the calculator, and if we use 0.00416 for this example, the answer that we're getting should be 1,282.85. The answer we're getting for the third one, if we use 0.00192 for this, should be, and I wrote it down below there. Let me get rid of some of those things. Oh, I must have erased, sorry. I will get it back from the calculator, which I have open here. It should have been 1,283.20. So I didn't want to refilm everything. I just thought it would be an interesting discussion, because if something in math doesn't make sense and you think that it should make a specific amount of sense going one way, see, it went from a lower number to a higher number, and we would have expected this one to be a higher number, which is exactly what should happen. It's a good idea to double check your answers sometimes, and the answer should be going up. And what that means is the more the compounding frequency is frequent, so the higher the compounding frequency, the more money you should actually be making. Now, I think the regular banking compounding frequency is monthly, and I think that's the standard pretty much everywhere, but there may be some institutions that give you different compounding frequencies depending on how much money you invest, okay? So this is saying that the final answer should be higher than the rest, and the issue is rounding issues. So just be careful on how much you round. And if this does ever happen in an assignment, obviously I will give you the benefit of the doubt because of the rounding, but just be aware that the higher the compounding frequency, the more you should be making money, okay? And that's a general idea. So that's going to be it for today's lesson. I'm just going to double check I have no more slides ready. That's right. If you have any questions, please let me know in email as always, and there will be some homework questions assigned in the Google Classroom regarding this, so please make sure to work on those. We will talk to you tomorrow. Have a great day.